Now we're developing the standard form of an equation of a circle. So we are going to get to that, but I think we want to do one more example so we can really understand why we're doing what we're doing. Say we want to find an equation for all points that are a distance of 3 away from the point -1, 2. So I have a graph here. Let's just graph the point -1, 2. And if we're trying to find an equation for whatever is 3 units away in all directions from -1, 2, that means up 3, down 3, left 3, right 3, out 3 in every direction. Notice what we are finding. We're really finding the equation of a circle. And I would welcome your generosity in calling that a circle. So notice what -1, 2 is about the circle. It's the center. Notice what 3 is. 3 is the radius. So we know that this is the point -1, 2. We're trying to figure out how could we find a formula or an equation that would give us a relationship between the center and the radius and every other point on the circle. Well, the -1, 2 is 3 away from all of these points. So let's use the distance formula. The distance is 3, so the distance is equal to the square root of, and remember the distance formula, x minus x squared, y minus y squared, okay? So this stands for any general x and y. It could be anywhere 3 units away from -1, 2. So x minus -1, quantity squared, plus y minus 2, quantity squared. Now we're interested in an equation, which this is an equation, but we would like for this to be a little more friendly in its presentation. Namely, we're going to get rid of that minus and negative, we're going to change it to plus a positive, and then we're going to get rid of that radical. Well, how might we get rid of that radical? Well, we can square both sides. In doing so, we get 9 is equal to, so squaring the square root, pop that off, x minus -1 is plus 1, quantity squared, plus y minus 2, quantity squared. When we have a general form or a standard form in this case, we would tend to put the variables on the left. So the standard form of this equation is x plus 1 squared plus y minus 2 squared is equal to 9. Notice in the equation, when we have this form given to us, we can readily see the connection between the center and the equation. When that's x plus 1, the center has an x value of -1. When this is minus 2, this has a y value of 2. And the radius is the square root of 9, which is equal to 3. That leads us to, I don't know if you hear that in the background, but my dog is having a bad dream, so she's making some sad noises. Standard form for an equation of a circle is if your circle has a radius r and the center is at HK, you're going to be seeing a lot of that, so get used to that HK. Then the equation is x minus the h, quantity squared, plus y minus k, quantity squared, is equal to r squared. All right, so let's say we are actually given the equation of a circle and we're asked to sketch the graph of it. Well, it would be nice to know 2 pieces of information. One is what is the center of the circle, and one is what is the radius. Well, the center of this circle, h is 4. K, think about if this was a minus, it would be minus -3. So -3. Center is at 4, -3. I always just think of it as the opposite. That looks like -4, so it's a 4. That looks like +3, so it's actually -3. The radius is going to be the square root of 12. And since we are going to graph it, we're going to want to know an approximation for that. It's about 3.5. So we'll go to our center, 1, 2, 3, 4, 1, 2, 3. Sorry for that annoying watermark. And from here, we'll count up 1, 2, 3.5, right 1, 2, 3.5, down 1, 2, 3.5, and left 1, 2, 3.5. And we will do our best to sketch in a circle. That one is better.